All right, welcome to today's last session. Today's last session would be before we open up for Q&A with Brian and Frédéric at the end. This interesting session would be with Frédéric Desbiens. Frédéric is planning to talk about do we really need Kubernetes in the edge? I guess the answer, everybody knows the answer. It's just more of a teasing question and an interesting title for an interesting session. So just to give you background about Frédéric is the program manager for IoT and edge computing at the Eclipse Foundation. He helps drive communities of IoT, Edge, and Sparkplug around various topics, open source innovation, etc. Frédéric previously worked as a product manager, solutions architect, and developer for a number of companies, Cisco, Oracle, Pivotal, etc. He holds an MBA in e-commerce, a bachelor degree in computer science, and a bachelor degree in history, and all from University of Laval in Quebec. So today's session, as I said earlier, do we really need Kubernetes at the edge? I'm going to leave the introduction of the session to Frédéric, and stay tuned. Frédéric, mic is yours.
Thank you very much, Hassan. And I should highlight, since maybe we won't have the time after that, Hassan is my close accomplice at the Eclipse Foundation. Is our marketing manager for IoT and Edge. So thank you, Hassan, for all your support. Now, do we need Kubernetes at the edge? So really, the aim of this session is to think together about a topic that's really important. As cloud native and DevOps have taken the world by storm, you would think that when we build applications and solutions that go outside of the data center, that the tools and approaches that you already know would apply in that space outside of the data center. And that's not necessarily the case. Sometimes yes, sometimes no. And so together this afternoon, we'll try to have a reflection on this topic. Now, please feel free to ask questions or post comments at any time in the chat or using the Ask a Question button. I will try to keep an eye on that and address the questions as we go, since we have plenty of time for this session. Okay, so do we need Kubernetes at the edge? And the answer there would be maybe. It depends. And it depends on what? Well, we'll see exactly. The whole point of the presentation is to raise or highlight the things you need to think about in order to make an informed decision. Kubernetes is great technology. There's no doubt about it. There are tools that are specific to edge computing, and just trying to plant a few seeds there and help you out making the right call for your specific project. All right, so our agenda for today, first we'll take a step back and I would just ensure that we are all on the same page, trying to throw around a few definitions. Then we'll spend time thinking about what are the typical edge computing workloads, and everyone will say, hey, that's AI, and yes, but there's much more than that. The third segment will really be, okay, we'll have a look at how you can deploy Kubernetes at the edge, what are the alternatives there, what that implies. And finally, we'll highlight something that was covered a bit in the panel this morning, but in this case, I'm taking a higher view of those things. So Edge Ops, the vision that we at the Eclipse Foundation have for edge computing and how it ties to cloud native and everything else we have in the Eclipse toolkit. Okay, so definitions. Let's start with the cloud. What is the cloud? And essentially, the cloud is on-demand availability of resources. And you saw that many times today in the other presentations. We had people scaling up and down things in a web console and things like that. And so the cloud is essentially about three things. First, you have a set of homogeneous instances. And typically when you start a virtual machine on AWS, Azure, whatever, you have an instance type in mind. Oh, I will start a C2, I will start a M4 or something. And when you say that, this is literally a specific quantity of compute power, memory, storage, etc. And obviously you can parameterize it and really shape those resources in the way that makes sense for your use case. But typically, more often than not, everything is quite homogeneous in the cloud. Now, the second point of the cloud, and that's the whole point of the whole thing, is that it operates at a large scale. You have an amount of resources in the cloud that will probably surpass nearly everything that you have in most data centers. Private data centers in many organizations, only the very largest of the large organizations would have more resources than, let's say, AWS or Azure have to offer in the specific region. So the scale is really large, and it's all centralized. You connect to a single console, right? And if you work with a specific cloud, you know that URL by heart, so you type it and then you access all of your resources, even if there are availability zones or regions, things like that. Overall, it's all administered in a very centralized way. And what is the edge, given what we know about the cloud now then? And the edge is completely, well, no, maybe not completely, but it's on the opposite side of the scale, in the sense that edge computing is about having resources anywhere and everywhere in the physical world. So it's obviously completely distributed. There's no central location. And yes, you can have what they call edge data centers and things like that. And yes, those things exist, but ultimately, if as you go further and further away from those data centers to the actual devices that are in the field, okay, everything is pretty much distributed and relying on connectivity technologies that are decidedly not data center type of technologies. Then there's the fact that the edge is operating as a small scale. And now you will interrupt me and say I'm wrong, in the sense that when you think about it, let's say monitoring all of the wind turbines that there are in a specific country, or monitoring pipelines, or monitoring water, public water equipment for a specific local government, those things are operating obviously at a very large scale. But when I say small scale here, it's about the compute resources. So the fact is, yes, maybe you are monitoring all of those wind turbines, but in order to monitor them, you deployed a little microcontroller or a very small server in the vicinity, and the resources, the compute resources at your disposal, the memory, the storage, they are all operating at a small scale. Okay, and so this means that if that particular device fails, you don't necessarily have the infinite resources of the cloud in order to plug that lack of compute resources or that lack of storage. So you need to think about edge in a very different fashion. And finally, there's the fact that edge resources are heterogeneous. There's no single stop shop in IoT and edge computing, which means that you have to deal with sensors from one company, boards from another, and then the boards will have characteristics that will vary from one another, and some of them will have an AI accelerator built in, some others will have one that's plugged over the USB port, etc. The thing is, when you talk about edge computing, the time scale of any project is completely different than the typical IT project. We're talking about, let's say, a digital building, or monitoring all of the locomotives offered by the Deutsche Bahn in Germany. When you do that, okay, you're implementing devices that are supposed to be in the field for several years, if not decades. And that's especially true in industrial automation, because most factories, they will keep their equipment for decades, and you have to operate in that kind of environment. So you have to deal with various generations of hardware, even if dealing with a restricted number of suppliers, since the lifetime of any solution is longer than what you see typically in IT. Okay, Now, if we are to have a look at a kind of formal definition for edge computing, this is what I put on the screen. So essentially, when we say edge computing, we're talking about providing compute, networking, and storage capabilities at the border of the network. Okay, and the network here is not just the Wi-Fi network or the Ethernet network, but or even fiber in the field, that kind of stuff. But really, you have to think here about a kind of field connectivity that's really closer to the source of the data. Okay, and that kind of field connectivity could be things like Bluetooth, Zigbee, Wi-Fi in some cases, LoRaWAN. There are so many alternatives in there. Okay, so the first part of the definition is really about that. You bring resources closer to the source of the data. So I bring whatever compute power I need closer to my wind turbines, or I install that on a locomotive, etc. But at the same time, there's the second half of the definition. Really, the whole point there is to maintain, up to a point, the kind of elasticity and concession-based pricing model of the cloud. So this means that more and more, as we will go forward, you will have providers of edge computing capabilities that you'll be able to rely on in order to deploy solutions in the field. Okay, now we've been talking about the cloud versus edge. Now let's just ensure we are on the same page when we say what cloud native is and what edge native is, and that's really important. So cloud native, there are various definitions, but essentially we probably can agree on what you see on the slide. First, cloud native is about DevOps, okay, a set of tools and approaches that we take in order to bring together dev and operators. Then it's agile, right? And it can take many shapes, it can take many shades, but essentially agile is core to the cloud native experience. And finally, when we say cloud native, and we've seen that throughout the day, this is about microservices, containers, and this is my pivotalness showing there: repair, repave, rotate, in the sense that you have those containers, and you won't hesitate to kill them, to recreate them very frequently, to ensure that you have the freshest versions and the most up-to-date versions of the dependencies, the latest patches in your containers and things like that. So really, all of that is not only technology, but a kind of mindset. And the mindset part, I should say, is probably something that applies very well to edge. What doesn't work is necessarily the full package because of the specificities of what edge computing is about. And some of those specificities, you see them on the slide. Okay, when you do edge computing, essentially you have devices in the field, robots, wind turbines, I've said that already, and you're trying to connect them to ultimately something that will be the cloud. And the cloud here can be private, public, hybrid, we don't care. Okay, somehow it will be all of that data that you are gathering, all of those actions that you are taking using actuators on physical devices in the real world, it will all go at some point to the cloud. But you don't want to connect those devices straight to the cloud. And why is that? Well, in some cases, the problem will be the latency. Imagine that you are automating a nuclear power station. Well, first, connecting that to the public internet is a very bad idea. But let's say you do it anyway, okay? Then there will be the problem of the latency, the sense that you cannot guarantee the latency between your device in the field and the cloud, which means that, hey, I want to take AI-powered decision in the field. Well, obviously, I have a sensor that returns some very concerning information to a server and then pushes that to the cloud. And then the cloud is making a decision to shut down the whole nuclear plant. But by the time the decision to do just that comes back to the device, it's too late, and you killed several thousand people because the whole nuclear plant has exploded. Okay, and all of that is common to several use cases in edge computing and IoT, in the sense that more often than not, they are related to infrastructure that has a direct impact on human life. Okay, like a connected car, for example, with autonomous driving. Okay, so in any case, the latency is too unpredictable between your local network and your device up to the cloud and back. And that's why in some cases you need edge computing in order, let's say, to deploy a smaller and quicker AI model closer to the source of the data to make a decision. Then there's the whole bandwidth aspect. A big thing in edge computing right now is video analytics, right? The fact that you put some machine learning and AI in the field and you check those video feeds and you want to do something with that in real time. For example, I could detect that there are burglars, let's say, inside my store, or I could use the video feed to detect that there's a huge traffic jam forming, and I immediately take measures in order to shape the traffic in a different fashion. But if you collect that video in the field and send that in real time to the cloud, I mean, just a single full HD video feed, okay, for 1 hour will probably be around 2 or 3 gigabytes of data, depending on how good you are compressing the video signal. And multiply that by several hundreds of thousands of cameras in the field, then obviously you will have a massive bandwidth consumption that will obviously result in a massive invoice. And obviously, whatever connected provider you have will be very happy, but your boss won't. You don't want that. So managing bandwidth and obviously doing those video analytics in the field makes a lot of sense. Then there's the whole resiliency aspect. Your network will go down at some point. And so, especially in the case of things that impact human life, you cannot afford all of those self-driving cars in the field to not make their own self-driving decisions on using onboard computers. You wouldn't do that in the cloud, because if the connection goes down, then all of those cars will start ramming into each other, for example. So edge computing is pretty much about, I need some level of resiliency, I need fault tolerance in my network. And then there's the whole data sovereignty aspect, in the sense that in many applications, whether it is healthcare, defense, even banking, sometimes you have regulations that say that the data cannot leave a specific physical location, like a hospital or a specific country, etc. And so edge computing is certainly instrumental in facilitating the job to implement solutions that respect data sovereignty. And that's another reason why you should leverage it. Okay, so given this, we have an idea a bit of what makes edge native different. Because if you think about it, yes, your ingress when you do cloud native applications, you will think a bit about it and you will try to optimize bandwidth, but ultimately you have elastic resources, and it's you will try obviously to optimize for cost, but then any caching you will do or things like that will still be in the cloud, right? So in the case of edge native, it's really different. First, you have to architecture according to the fact that the network will degrade or fail at any point in time, which means if you are gathering data and crunching it locally, well, obviously you can simply do your local analytics and send an aggregated report later to the cloud, and that's it. The second thing is edge native is different because you need to optimize for typically both size and power at the same time. So you're trying to save on resources. So obviously cutting the fat in your code is really important. You need to minimize storage consumption. You need to minimize memory consumption, especially since the kind of environment that you have doesn't have an infinite amount of resources. And you need to optimize for power because in some cases you need to operate on battery for several years even. And so this brings a different mindset. And obviously the third aspect of edge native, which is really different, is that typically you will want to operate in a zero trust security model. And by that, when we say zero trust, it's literally by default, no device is trusted by the infrastructure. So you see all devices as potentially suspect, which means that you need to take specific design decisions and obviously specific real-time monitoring in order to ensure that no device has been compromised. And if a device has been compromised, maybe you will quarantine it, or maybe you will mark the data as suspect for future review up in the cloud at some point, etc. So there, depending on the use case, zero trust will mean many different things, but ultimately the one thing you should remember is that every device is potentially suspect. You don't trust anything by default. Okay, so we now are on the same page, I hope, at least, on the basic concepts and principles of cloud native versus edge native. Let's dig now a bit deeper about the kind of workloads we run at the edge, and we'll see this has a direct implication on whether you and I should be using Kubernetes or not at the edge. Okay, so first, a very important thing, and this is something we highlighted in this morning's panel, is that there's a bit of confusion in the market right now, in the sense that when people say edge, they all say a slightly different thing depending on the vertical they are talking about, or depending on the specific use cases they have implemented in their platforms, etc. Okay, so you will hear things like far edge, near edge, telecom edge, etc., etc. And in our case at the Eclipse Foundation, in our Edge Native Working Group, we settled on this view that essentially from the edge to the cloud is a complete continuum, and storage, networking, compute resources can be deployed at any point, any physical location between those two extremes that are literally the edge. So that's literally my board on a locomotive, or my little server around a set of wind turbines or something like that, and all the way to the cloud. And once again, cloud here is private, hybrid, public, whatever, multi-cloud, we don't care. Okay, so between those two extremes, okay, there is an infinite set of physical locations, and depending on your use case and the topology you choose, the components for your control plane, your data plane, your management plane, they will be in various places all over this continuum. And that's really something you have to remember. Now, when typically we're talking about the planes over the continuum, just to make sure, once again, we are saying the same thing. The data plane is where the software components are being deployed. The control plane will control the apps or the infrastructure. That's where you do your real-time monitoring. And finally, the management plane here will be the place where you manage the applications and infrastructure. And that's where typically you will do the configuration for your edge devices and things like that. Okay. So we at the Eclipse Foundation run surveys every year in order to understand what IoT and Edge developers are doing. And in the latest edition of our developer survey, that the 2020 edition, the 2021 edition is underway, by the way, so you can still participate. It closes tomorrow. But in the 2020 edition, we asked people, hey, what's your number one edge, or what are your top? I think we allowed at least 3 choices there. Anyway, so what are your top edge computing workloads? And no surprise, artificial intelligence, machine learning was the top one. But as you can see, it got only 30% of the votes. And people could pick multiple choices, so obviously it adds to more than 100% here. But control logic, data exchange, and sensor fusion were the following 3. And those are very different things. Control logic is essentially in industrial automation, you have robots or industrial equipment in the field. Data exchange, well, obviously you're moving data that has been acquired in some place to another place. And sensor fusion is the enrichment, obviously, of sensor provided data, and then it's pushed later to the cloud. And then there were several other choices with a significant amount of votes. I'm just showing the top 4 here. All of this to say that, the type of deployment that you will do, the type of management you will do for AI is not the same for control logic, and the constraints that you will have are very different. So edge computing is very diverse, and this means you need proper strategies to attack and deliver each of those very different workloads, essentially. We also asked in the same survey if people, I was about to say if people were using containers. It's a bit more than that. We asked them, how are you deploying the code that you are running at the edge? And then, okay, top choice was containers, but you see a significant amount of people, of respondents told us that they are doing native binaries and then script files and things like that. So once again, yes, containers are highly useful and relevant, but in some cases, for various reasons, people are not using them. Okay, and obviously, once again, people could pick more than a single choice to that question. And more often than not, we'll use containers plus something else in order to deliver. But that's once again, that's really important, because obviously if you're not running in a container, well, maybe you don't need Kubernetes. We also asked people about their deployment strategies, and over-the-air updates were the overwhelming winner, but there is a really important finding on this slide, in the sense that 48% of people told us that they are doing cloud-managed updates versus 42% that were doing locally managed over-the-air updates. And when we say that, it's literally that there's an air gap. In other words, you have some over-the-air server in an environment that's not directly connected to the internet. And in a Kubernetes perspective, this means you have some kind of local container repository that you need to manage and keep updated, etc., etc. And that kind of environment obviously is more secure, in the sense that you are not putting random things from the public internet. But at the same time, it's certainly very different than a cloud managed environment. And 38% told us that essentially, in order to deploy new code, they simply take a crossover cable on their laptop and then publish updates like that. And in some cases, that's what you will need to do. Once again, all of those locomotives, you don't necessarily connect them to the public internet, or all of those wind turbines, but you will go there on site and then push some sort of firmware update, let's say on a controller or something like that, depending on the type of functionality you have. And once again, this is really different than what you do in the cloud, right? Okay, now Kubernetes at the edge. Should we be using it or not? And what kind of Kubernetes is available at the edge? And that's an important question. So right now, and there are probably lesser known options, but essentially if you want to run Kubernetes on some kind of edge device or in an edge environment, you will have three options. The first one on the left is a pure vanilla Kubernetes, and on or whatever standard distribution you will find from heavyweights like Red Hat, for example, with OpenShift or whatever. So in this case, there are several redundant components. You have several instances of the cloud controller, the kube controller, etc. But all of that is tied together by the kube API server. And obviously, a critical component in that kind of environment is your etcd database, because, well, essentially, you need to save all of those configurations and real-time information about the state of the cluster and things like that. Okay, and that's what you get in your control plane. Now, in the data plane, so really at the edge, you will have your kubelets, the kube proxy that handles the networking, and obviously whatever container engine is provided by the underlying operating system or the underlying infrastructure. So, for example, you wouldn't necessarily consider Project Eve to be a full-blown operating system per se, but certainly it provides a set of services and a container engine for you to run on. Then in the middle, we've got K3S, and K3S is, a lower footprint option where essentially you package lots of the complexity that's in Kubernetes in a kind of big fat executable in the middle. But when I say fat, in fact, I should have said a big lean executable, since certainly it's much easier on resources than vanilla Kubernetes, and it adds a few components of its own, like the metric server, networking, load balancing, that kind of stuff. And here, instead of having etcd by default, it will rely on an in-memory SQL-like database in order to persist cluster configurations and stuff like that. And then on the data plane side, you have your K3S agent, and once again, the container engine provided in the environment. And finally, there's KubeEdge. KubeEdge takes a different approach where essentially it will extend an existing cluster, an existing control plane. So that's why you see at the top the API server. And then essentially there's the cloud core component of KubeEdge that provides an edge controller, device controller, a cloud hub. Okay, so that's where the KubeEdge cloud functionalities reside. And then you have this edge hub that's deployed, literally at the edge. And then you can have device abstraction layer or standard container engine as the runtime. So it's a bit different and flexible. And those are the three mainstream options that you have if you're thinking about running pure Kubernetes at the edge. And each of them has its own benefits and downsides, but certainly if there's one thing that has been highlighted in other presentations, it is how painful it can be to manage yourself a plain vanilla Kubernetes infrastructure, since you have to assemble not only the cluster itself, but many of you need to deploy alongside it many other components in order to deliver a full set of features. And so extending that at the edge by yourself is certainly problematic at times. So certainly this is why K3S and KubeEdge have found certainly an audience in the market, because they simplify and they have an opinionated vision of what it means to run Kubernetes at the edge. And certainly the whole footprint for those two solutions is smaller than plain vanilla Kubernetes. And if you are interested in learning more about the memory footprint, network footprint of K3S and KubeEdge compared to plain Kubernetes, I put a link, since this particular diagram, I took it from a scholarly article published by a number of people I know. And essentially, you have the link to the article on the slide that you can click. And this will lead you to IEEE Explorer. If you don't have a subscription, I can share with you a pre-publication version for free. So just reach out to me on Twitter or LinkedIn, and I'll be happy to share a copy of that particular paper with you. Okay, but the thing up to now is we were thinking about running Kubernetes at the edge somehow. But if we don't want to do that quite, but rather maybe have Kubernetes in a kind of field data center, and then maybe run something else, at the infrastructure level, etc., etc. So in this case, I put on this slide, and once again, this is adapted from the article. I expanded on this table, but essentially here are other options that you can use in order to run Kubernetes or integrate with Kubernetes at the edge. And an example of that is the Outposts by AWS. So that's literally servers that they install with the actual AWS code somewhere in the field, right? So it offers Kubernetes as an option. So you can certainly, if you wish so, run Kubernetes workloads on that. And then we have our own homegrown Eclipse options, FogOS and IOFog, that I will cover later. Both are cloud managed, and they can run in standalone mode at the edge, but they can be integrated with Kubernetes. And in the case of FogOS, you can run binaries, containers, or VMs. In the case of IOFog, you can run containers. Then there's Ajax Foundry that typically you will run as a set of containers on the top of something, but that one is particularly oriented towards IoT. There's Fledge, which is an interesting other project from LFEdge. That one is really targeted at Industry 4.0, but you will notice that those for two options, it cannot run in standalone mode. So, and it doesn't necessarily offer direct Kubernetes integration. So it's running on the top of it is not necessarily aware of the infrastructure underneath. And then K3s and QBEdge are in the table. We covered that. And there's Open Horizon, which is more a solution to deploy workloads and things like that. But certainly it offers Kubernetes integration, and you could leverage that. So there are plenty of options in there. And as you see, some of them are pure Kubernetes, some of them are integrating with it. And whether you need a Kubernetes instance somewhere in the field or not really depends on, well, your specific use case, your requirements, etc. So now let's have a look at two specific use cases. Okay, when you think about the modern car, okay, and not just the modern car of today, so to speak, you know, cars with semi-self-driving capabilities, but the type of cars we hope to see in 10 or 15 years from now. Those cars are chock full of sensors. They integrate several computers. They are literally a data center because everything is linked together with a high-speed local network. So should we be running Kubernetes as, you know, the orchestrator for the workloads in the modern connected car? And the question for this, well, the answer for this depends on how confident you are in Kubernetes capabilities, or even in a container's capabilities to deliver some of the features we see on the slide. And here, I really focus on the car itself, but there's the whole dimension of vehicle to anywhere communication or vehicle to vehicle communication. If you have several self-driving cars on the road, that's certainly another very useful dimension. But let's focus on the subsystems of a connected car. So some of them maybe will be about mobility management. So essentially routing, you know, choosing a route according to the traffic conditions. Some of them will be about the management of the vehicle itself. So the fact that there's a recall on it, for example, and that you need to go to the garage for repairs. Some of them will be about predictive maintenance to tell you that there's too much wear and tear on your brakes and you should then get serviced. And all of that happens more or less asynchronously in the sense that it's fine if you miss it, you can always do it tomorrow or something like that. But then there are active safety features in the vehicle, for example, lane departure warning or you know, imminent collision warning or avoidance, driver assistance features, whatever they are. And those things in most cases, they have a real-time dimension, in the sense that in order to save somebody's life, you know, you need to make a decision in 5 microseconds or less, let's say. And then comes the question, do I want to run those workloads in a containers on the Kubernetes cluster that maybe will decide I need to kill that container for whatever reason? Maybe not. And obviously, you could tweak your cluster in order to whatever, but yeah, in most cases, in fact, what you will want to do there is to run a real-time operating system on a specifically constrained environment and things like that. And you wouldn't run that as a plain workload like the one that you are running on the vehicle's entertainment system, for example. So out of this to say, there are many, many considerations to be had. And maybe I could leverage Kubernetes to orchestrate some containers in a connected car, but certainly it wouldn't be up to snuff to orchestrate all of the potential workloads, and especially the life-saving, mission-critical components in the car. We say that the modern factory is a data center as well, right? Robots all over the place, video analytics, computer augmented vision, augmented reality for the humans on the shop floor. So would it be a good idea to run Kubernetes there? And once again, the answer is it depends. So I put a little diagram there that comes from the Eclipse Basics project, because I felt it was a good representation of the modern factory. So this diagram shows you that there are several layers of compute resources on any factory. You know, some of them are plant level, let's say the ventilation, heating and cooling and things like that. And then some of them are, you know, specific middleware that you run on a blue non-real-time network. So there's the standard IT network, so to speak, in blue in this diagram. Okay, and then there's a real-time network, okay, in red, and there you have specific varied components in the field, robots and things like that, and this goes at the field level. You see that there are processors running, so essentially you will have programmable logic controllers or PLCs that execute specific workloads in order for robots to assemble a car, for example. Okay, and so certainly Kubernetes has a place there, maybe more in the middleware layers and up. But once again, if you have any real-time component to this, maybe you don't want to put that necessarily in containers, or if you put it in containers, you will have very different operational conditions to this. And maybe then using a tool to manage those containers that has been built from the ground up for the edge would be a good idea, because the connectivity conditions vary, etc., etc. By the way, Eclipse Basics is a full set of software components for industrial automation. So it's both a research project and a full-blown open source project at the Eclipse Foundation. So please have a look if you're curious about industrial automation, and I put the links on the slide as well. Okay, so in the end, should I be using Kubernetes or not? Here are a few questions to think about, because as I said, the answer to that question is maybe, and there are several considerations to take into account there. First one, how predictable should be your latency? In other words, you know, and I said this when I was talking about cars. Mission critical systems have real-time requirements, and then right now, I wouldn't trust Kubernetes with real-time workloads. Then there's a question, can you afford to lose data? So let's say I'm capturing air quality data in a city to ensure that, for example, we close the roads if there are too much pollution. If I miss that decision, let's say by 5 minutes, because there was a set of sensors that were offline, there was a network outage, is it okay for me to lose that data? Probably. It's not ideal, especially if I do machine learning. It will skew a bit my data sets, but no human will be harmed if I lose that data. Whereas if we're talking about the braking system of a connected car, of an autonomous driving car, then obviously getting to the decision maker in the car, the decision making component in software, the fact that there's a pedestrian in front of the car that we should be braking, you cannot afford to lose that. And certainly the design that you'll be doing will be very different. You can ask also yourself, how stateful is your application? We all know how painful stateful workloads are on Kubernetes. And I mean, there are efforts to improve that, but it's still painful, okay? And there's the question of instance uniqueness, in the sense that, okay, typically in cloud native, we have a full, set of pods that we are killing, but it's fine. We can scale on another part of the cluster, and it's perfectly fine since we are stateless. But as we are, once again, doing things that are stateful or mission critical, well, those instances become unique, and that's really an important consideration. You cannot afford to lose those containers because literally people could die, for example. Another question to ask yourself is obviously, how constrained are the edge nodes and infrastructure that you have? So obviously, if we are dealing about microcontrollers with limited amounts of compute power and memory and storage, then obviously you are very constrained. But then you can have maybe some amount of spare capability. But once again, okay, managing that in some cases will be better left to specialized platforms that really understand that are hardware aware, and this is where edge computing platforms do so well. And finally, another question to ask yourself, how far should be your control plane, physically speaking, from the edge? I mean, in some cases, maybe there are field data centers you can leverage. In some cases, you cannot. So in other words, you should ask yourself, how autonomous are your edge devices and servers? And this goes back again to this factor of resiliency. How resilient should be the whole solution? In some cases, it's perfectly fine if I have an outage, and in some others, it's critical that everything stays online all the time. And this, once again, will steer you in one direction versus another. And in the end, in most cases, you will end up using edge computing platforms at the very edge and some form of Kubernetes somewhere, whether it is purely in the cloud or at some location closer to the edge device. Okay, so the answer is certainly a mixed one in most use cases, especially as you're trying to scale a solution in the field. Okay, and all of this to say that ultimately it takes a complete village to build the edge. And so this is not just about Kubernetes, but about a complete set of potential components, open source components in this case. There are no commercial solutions on this slide, but that you can leverage in order to deliver edge computing enabled solutions. And the logo in color are Eclipse projects or Eclipse initiatives like Jakarta Hihi. And then all the ones in gray, it's not that they are not good, but they are not Eclipse. But we collaborate with those projects. And in fact, the Eclipse Foundation is now a member of LF-Edge, for example, and LF-Edge will be shortly joining the Eclipse Foundation as well. So we work in an environment where essentially by focusing on our little part of the edge to cloud continuum and the development to operations continuum, we can provide a set of solutions that you can leverage in order to build solutions that make sense for your industry or for your use case. So this is not just about Kubernetes, but really taking a step back and looking at the wider ecosystem of potential components is really, really important. But the one thing that this diagram shows for sure is how extensive the Eclipse toolkit is. As you can see, we are all the way, in all the places that count on the edge to cloud continuum. And certainly we have plenty of DevOps chops to show as well. Okay, now very briefly, in the interest of time, what is the vision of the Eclipse Foundation for edge computing? Well, this is what we call Edge Ops, and we covered that in this morning's panel, so you can watch the replay for that if you are curious. But in a few slides, I put the most important facts. And a reminder, we have a handy dandy white paper that you can download to really learn more about DevOps. So you have both the URL and the QR code on the screen that you can leverage in order to get your own little copy. Now, Edge Ops is really about adapting DevOps for the edge, because essentially doing pure DevOps at the edge would be madness. And we discussed already why that would be. So really, Edge Ops is taking into account the challenges of the edge, latency, bandwidth, resiliency, we covered that already, and really taking into account the characteristics of edge solutions, the fact that they have a longer lifespan, the fact that they deal with heterogeneous components, the constraints in power consumption and compute that you have in storage, etc., and obviously the various connectivity modes, and really taking into account the workloads and artifacts, the strategies that I covered about edge as well. So you take basic DevOps and you tweak it according to what you see in the second layer on the slide, and essentially you get DevOps. Edge Ops, I should say. And at the Eclipse Foundation, Edge Ops is just part of the puzzle. So this is our wider IoT and edge infrastructure. And you see there are many, many concerns in there. And on the next slide, you see all of those project logos. So essentially, apart from a few specific functional concerns in there, like operating systems, real-time OSs, we don't have yet anything in that space, but we work, let's say, with the Linux Foundation on the Zephyr real-time OS, for example, and things like that. And obviously, Linux is highly important and relevant to us as well. But essentially, we have a very comprehensive toolkit in there. And not only that, but we do with our sister organization, the Open Hardware Group, we even are doing open source hardware using RISC-V, the RISC-V architecture. All right, all of that exciting edge-oriented action at the Eclipse Foundation happens in our Edge Native Working Group. And essentially, the whole point there is to be code first. So we focus on our projects, not so much on abstract blueprints. Our goal is really to simplify and streamline production edge deployments, and really Edge Ops is the cement that brings everyone together in our working group. So those are the current members. And one exciting things we have there is that we have companies like Bosch and Huawei that essentially bring to the table not just their IT chops, but their know-how of industrial and IoT solutions. So this is not just a bunch of IT people talking to each other in a dark room. The three projects that we have under the Edge native mantle, so to speak, are Eclipse IO Fog, Eclipse Fog OS, and Zeno, and we'll cover each of those in turn in the next slides very quickly. So Eclipse IO Fog is a centralized take on edge computing. And essentially, by default, it can run in standalone mode, but it can integrate with a remote Kubernetes control plane. And the way this works is IOFog really does container orchestration. And so you wire together microservices, you write descriptors for those microservices, and you wire them together, and developers can take advantage of those services when they are deployed in the environment. IOFog abstracts the details of the physical networking and all of that, so it's fairly easy to use, and it integrates a level 7 proxy, so an application level proxy that enables you to bring together various deployments all over the world, over the public internet, without having to use a VPN or anything complicated like that. Then there is Eclipse Fog OS. Eclipse Fog OS takes a completely decentralized take on edge computing, and really it enables you to provision infrastructure in a unified compute fabric, okay, stemming all the way from the tiny microcontroller all the way up to your cloud infrastructure. And it follows the multi-edge computing principles or network function virtualization principles defined by ETSI. So it's certainly a good platform if you are somehow involved with telcos. And really recent features that have been added to the platform include bidirectional Kubernetes integration and an end-to-end resource allocator. And finally, there's Eclipse Zeno. Zeno is a pub/sub protocol optimized for edge deployments. It integrates the notions of evals and distributed queries. It integrates zero copy, so it's very low overhead protocol, and you can run it on TCP, UDP, or even Google Quick. So depending of your requirements for power consumption, this is really handy. All right. So if you want to learn more, please, follow us on social media, try out IOFog, Fog OS, and Zeno, join our working group, and certainly our public meetings are always open to new friends, so don't hesitate to knock on our door. And thank you so much for watching my presentation today. I certainly appreciate you being here, and if there are any questions, well, now would be the good time to ask them.
Yeah, great. Thank you so much, Frédéric. Great insights, like always. As easy as it can get. We're going to open the floor right now for some questions, and we'll probably blend in the last session right now with Frédéric. So if you guys have any question at all, please feel free to either press the ask a question button or just type it in the chat box.
So my question to the audience there, if you, dear audience, don't have questions, would be, have at least some of you dabbled a bit in edge computing? Maybe you can give me a +1 in the chat or something. Or was this topic completely new to you before attending this day? So will we get some answers, or did I bore everything or everyone to death?
Oh, well, we'll have to see.
Uh-huh. All right, so Merlin, certainly a +1 there. So that was new to you, +1, new. Okay. In any case, if it was new to you, certainly the white paper that that we wrote together on EdgeOps is full of information that will be helpful to you to figure out, and certainly the Edge Native website at edgenative.eclipse.org is another good resource. And feel free to join our public Slack workspace for the workgroup as well if you have any questions about Edge Native development. Certainly we'll be happy to have you there. Now I see a question from Harry who's asking, can you explain more about why the Eclipse Foundation and LF Edge are collaborating? Well, absolutely. The Linux Foundation, generally speaking, is certainly a co-competitor for us in the sense that we collaborate where it makes sense, and obviously we each try to build something that we think is the best on each side of the IT market. Now, in this particular case, we are collaborating because essentially, when you look at what LF Edge contains, it's pretty much about core infrastructure. Kubernetes itself, but LF Edge contains things like Acreno that are blueprints. It contains things like Fledge and EdgeX Foundry about IoT use cases up to a point, and then Industry 4.0, but pretty much in an infrastructure-centric perspective. Whereas at the Eclipse Foundation, we have development tools as one of our 4 strategic pillars, as Brian highlighted this morning in the opening keynote. And Edge and IoT is another of those pillars. So we pretty much have a kind of developer-centric view, much less infrastructure-centric, which means that what we have in the edge computing space is really about application management and developer capabilities and this EdgeOps mindset. And when you compare that to what they have at LF Edge, it pretty meshes together quite well, in fact, because although they have something like EdgeX Foundry, which is IoT oriented, you can take EdgeX Foundry and run that on Eclipse IO Fog in containers, for example. And for us to come together and each work on where we have our strengths makes complete sense. And ultimately, if you ask me, I'm pretty much non-religious about this. Anything that consolidates open source is a win, whether it happens at LF Edge, whether it happens at the Eclipse Foundation. So it's about, I think Boris made a very good comment in the chat. It's collaboration over competition. Yes, we compete up to a point. And obviously, we hope that if you're thinking about doing edge computing, you will pick Eclipse tools and platforms. But ultimately, Kubernetes is there to stay. We have a joint working group with the CNCF on matters around edge computing. So, it makes sense for us to collaborate in open communities and come together as one, as a larger open source community. So I hope, Harry, this answers your questions.
And Harry, just +1 if you are the Harry Forbes from ARC Advisory Group.
Okay, and we would be obviously happy to elaborate more, Harry, in a offline conversation and explore what that means to you. Are there any other questions or even comments about the day? Anything really that makes sense to you? All right, so it seems at least just for little me, there are no further questions or comments. So do we have other potential victims for the final Q&A, Hassan, or what's happening there?
Yeah, I guess I guess we're gonna be wrapping up quickly. If no potential questions would be added here. I have as well Brian. If there's any specific question, I can pull Brian to answer any cloud related. Other than that, I think we'll call it a day. So on behalf of the Eclipse Foundation and the Eclipse Working Group, I would like to thank all the attendees for the great participation. I must say it was pretty active participation today, and I'm happy to host the event on behalf of the foundation. I also wanted to take the opportunity as well to thank my colleagues who are today, Frédéric and the rest of the team who are working from Canada, although it's a Thanksgiving holiday. So thank you for the time dedicated here. It's highly appreciated. Brian, Clark, rest of the team, thank you so much. And until we meet, we will have all the material ready for you on our social media channels, as well as the YouTube Eclipse Foundation YouTube channel. We'll be as well adding all the presentations material in the description part for all of the folks who would like to have a reference. In the meantime, folks who haven't yet participated in IoT and Edge Developer Survey, please do so. Tomorrow is the closing day. We can't wait to collect all the responses and come back with interesting reports and key findings on the week of November 30th to December the 7th. Until then, I must say stay safe, and please join us at EclipseCon 2021. That's where all the magic are happening. Thank you.
Absolutely. And a big thank you to you, Hassan, our master of ceremonies. So you were outstanding as always. So a big thank you in the name of the other speakers for your support throughout the day. And yeah, please enjoy the rest of Thanksgiving, since you're based in Canada as well. And you took time away of your family to be here. So really appreciate it.
Thank you, Frédéric. Thanks. Oh, Harry, happy Thanksgiving. Yeah, not at the moment. We do have the travel budget is open for us to travel, but if there's anything exciting, just let us know. Just let us know.
Absolutely.
All right. Have a great, nice afternoon and evenings for the folks in different time zones, and we'll speak soon.
Thank you, everyone.
Thank you all.